Hi, Bruce from Shining 3D, and today we'll talk about 3D metrology scanners application in foundry and casting industry. The foundry and casting is a key part of manufacturing, providing essential components for a wide range of industries, including automotive, aerospace, construction, and consumer goods. 3D scanning is a process of capturing the physical shape and appearance of real-world objects using a variety of technologies. In general, there are 5 applications of the 3D scanning: reverse engineering, or 3D scan to CAD, or 3D modeling; 3D inspection, CAE, and visual assembly; connection to 3D printer for 3D printing, and virtual reality, or online display. Reverse engineering and 3D inspection are most popular applications. Here are some tools used in the traditional measurement in the industry: steel ruler and vernier caliper. It's a common measurement tool for measuring the length, outlet diameter, and inner diameter, dips, etc. Calipers. Those calipers are used to measure the out diameter and inner diameter of thin mold or thin core, groove, radius, etc. Feeder gauge measure the thickness of the gap. Those tools are not very accurate, time consumer, and easily affected by operators. CMM machine and scan arms are 3D measurement tools. Coordinate measuring machine advantages are highest accuracy and precision. Disadvantages are high investment and running cost, strict requirements on environments like humidity, temperature, and vibration, time consuming for full-scale measurements, and difficult to measure parts with confined and curved areas. Pros and cons of 3D laser scan arm. Pros: portable than coordinate measuring machine, easy and quick to measure, high accuracy. Cons: high investment, scanning size restricted by arm size. This is a short compare among 3 measuring tools. Measuring volume. 3D scanner has less limitation on measuring volume. It can work with photogrammetry system like Digimetric to extend measuring volume and still keep high accuracy. CMM machine and 3D arms measuring volume depends on table size and arm size. Accuracy. CMM machine has highest accuracy, while 3D arm and 3D scanner achieve similar level of accuracy. CMM machine cannot measure soft or untouchable material, for example, a high temperature casting part. 3D arm, if equipped with a laser scanning module, and 3D scanner can scan soft and untouchable material. All 3D tools can do 2D measurement. CMM probe and arm probe capture points slowly. It's time-consuming to capture more points. 3D scanner with multiple laser lines or optical sensor capture millions of points per second. Due to that, it's almost impossible for CMM machine and 3D arm probe to do 3-4 scale measurements: surface measurement, dimension tender analysis, virtual assembly, and 3D archive. 3D scanner and 3D arm equipped with laser scanning module can do that, while 3D scanner has higher efficiency. 3D scanner occupies much less scanning space than CMM machine and 3D arm. Benefits of 3D scanner: fast and accurate. As the laser moves across the surface of an object, thousands to tens of thousands of data points can be recorded per second, meaning your project can process faster. High accuracy. For example, Shining 3D free scan handheld blue laser 3D scanner, accuracy up to 0.02 mm or 20 micron. Good environmental adaptability. Temperature, humidity, light, and vibration have little effect on scanning, and 3D scanner can be used widely in the workshop. CMM devices have very high environmental requirements, and the anti-calculating arm must not vibrate. Portable, small package, easy to travel with airplane or car. Cost-effective, 3D digital inspection enables qualified and efficient quality control. User-friendly, easy and quick setups to capture and measure 4 dimensions, regardless confined area and dated angles. Film pattern, wooden pattern, metal mold, raw casting, fine casting, and fine milling are the typical parts, often 3D scanned by 3D scanner for reverse engineering or 3D inspection applications. Typical workflow for 3D inspection, casting, and foundry parts. First, scan parts with 3D scanners, get 3D data. Normally, it's STL format. Second, import scanning data and CAD data to 3D inspection software, like Geomagic Control X or Varios and align. There are several methods to do alignment. Popular methods are best fit alignment, RPS alignment, or 3-to-1 alignment. Third, create the deviation map or GD&T or other inspection items and export the inspection report. Let we watch a short video of 3D inspection process.
After that, we will use Ctrl X to compare the product data, which we just scanned, and the CAD file. Before we get started, import the CAD file and scan data to Ctrl X. You can directly drag them or click Import and select the file. You will see the CAD file is in the reference data and the scan data is in the measured data. We start with initial alignment, apply with default parameter. Then click Best Fit Alignment, also using default parameter and apply. Next, we can start the inspection using 3D Compare. Set the max deviation as an appropriate value and click Next Step to set your specific tolerance. Here we use 0.02 mm and click the check mark. The chromatogram will show on the object and the annotation on the right. The darker the color, the greater the deviation between the scanned data and the CAD file. Since this object is not exactly the same with its CAD file, you will see some red areas with high deviation. If you want to know the exact deviation of a certain point, use the comparison point tool and click on the object. The deviation value will show. Also, you can do some quick measuring on the dimension function. For example, simply choosing 2 planes to measure the angle using angular dimension. And click on circle or sphere to measure the radius by using radial dimension. Checking flatness and circularity is also really convenient, using corresponding tool and click on plane or circle. At last, Ctrl X can generate inspection report automatically by just clicking Generate Report.
Film pattern is made of expanded polystyrene film, which is created to coat a mold. The pattern is then vaporized or burned away when the melted metal is poured into the mold, even behind a precise metal casting. 3D first article inspection. Before casting, it's essential to measure the film pattern's deviation, compared it with designed CAD. Pre-scan UV series can easily scan and generate high accuracy and high detail 3D data in short time and on-site. Wooden patterns are widely used as prototypes for subsequent flip sand casting. As a pre-production process in the production chain, its dimension and shape directly affects the quality of the final product. Due to the extra large size of this workpiece, the wooden pattern X body is easily shifted during the production process. It needs to be quickly inspected in the full size by high-precision 3D scanning equipment like FreeScan UE Pro, which has built-in photogrammetry, to determine whether and what extent of offset. Here is another wooden pattern case. Customer requests supplier to create a 3D report, which includes color map and GD&T, like flatness, key dimension deviation. Root case analysis. When final goods are not qualified, we need to find the root causes. 3D scanner helps to find issues by inspecting parts and tooling in each stage of manufacturing process. Accurate and easy interrupt color maps supports the corrective action plan. CNC programming verify. This custom mold is made by a CNC milling machine. After 3D scanning and compared to the designed CAD, easily to find area overcut or undo, as well as reference hole position deviation. Virtual assembly. Wall thickness refers to the thickness of a casting wall component composed of the mold and core, core and core. Wall thickness inspection is one of the key dimension inspection. By scanning up parts and down parts of pattern, visual assembly is available in 3D inspection software. Wall thickness of cavity is then can be measured before casting. Like this extremely huge wind turbulent hub, it's important to control the dimension deviation and finish allowance of assembly position. FreeScan UE Pro has built-in photogrammetry working with the scale bars, very suitable to scan those huge objects and analysis after them. The anchor mouth is generally made of steel or cast steel, and core requirements in the manufacturing and installation process is not to jam the anchor. To achieve no anchor jamming, it's necessary to ensure that the physical object is consistent with the design structure during the manufacturing process of the anchor lip, especially the curvature of some curved surface. Maintenance and redesign. Chinese 3D scanners can scan components and generate an accurate 3D digital file, which can be used for reverse engineering or design optimized jigs and fixture design. Following video shows the general workflow of reverse engineering. 3D digital archive for future maintenance. 3D cross-line inspection is a technique used to inspect the surface of a 3D-dimensional object. FreeScan series can easily capture objects' 3D surface. In inspection software, we can slice and create crosslines. Compared with the designed crosslines, easy and quick to find deviations. Perpendicularity refers to the degree of being perpendicular, which means that two lines or surface meet or interact, set at the right angle, 90 degrees to each other. In other words, when two lines or surface are perpendicular, they are at 90 degrees to each other and form a right angle. Concentricity and coaxiality in the ISO standard is a tolerance that controls the center-derived median points of the reference feature to the datum axis. Like this 2 plus 2 plus 1.5 meters apart. To measure the perpendicularity and the concentricity, we use FreeScan UE Pro. Photogrammetry is adapted to ensure the accuracy. After 3D scanning in the geometric control X, it's easy to measure the perpendicularity and the concentricity. Zhuzhou Goldfront Foundry Corporation Limited is a production base of railway electric locomotive casting parts in China. As a professional supplier of casting for the world-class railway transportation equipment, it has a variety of advanced manufacturing and testing equipment. To accurately control the dimension of the castings, Goldfront Foundry has introduced the Shiny 3D FreeScan UE Pro. With the help of FreeScan UE Pro, the casting inspection workflow has been greatly accelerated. The inspection of medium to large size casting once required 1 or 2 days of a master technician, but now it only takes half to 1 hour. At the same time, the accuracy of dimension inspection is also greatly improved, which ensures the casting meets the design requirements and help high-speed trains running faster and safely. In the process of geological exploration and mineral extraction, the polycrystalline diamond compact drill is an essential tool. Dedicated design structure and hardness make it can bite the underground rock layer and obtain valuable underground resources. In this case, PDC oil drill will be scanned and 3D inspected. The PDC oil drill comes from a domestic oil equipment manufacturing company with over 26 years history. Due to the irregular shape, it's difficult to obtain the complete and accurate data quickly by using CMM machine and other tools. Key inspection items: the machinery allowance of the casting drill body and blade wing, the angle between the head position and the dimension and the diamond composite sheet, and the horizontal plane. With the Shiny 3D scanner, the benefits are inspection time from 1 day to 10 minutes. Previously, using CMM machine, one drill may take 1 day, while a 3D scanner about 10 minutes to complete the 3D inspection of one 80 cm high PDC oil drill. Expand the 3D inspection range. Before using 3D scanning technology, there were only few measurable parameters recorded. Nowadays, the high-precision 3D scanning it's possible to obtain the relationship between the position of diamond composite sheet in space and more accurately measure parameters that directly affect the efficiency of the drill, such as the height position of the diamond composite sheet and the angle between the horizontal plane. That's all for today's presentation. Let's move to the Q&A section. Thank you.